All right, you want to go?
Yep.
All right, everybody, welcome to Moulton. He's going to be talking about evidence you don't have.
Hey everybody, how are you? All right. So I know a lot of you already know me or have seen a lot of the talks and things like that, and usually they're extremely technical, and I'm going to try to do something probably slightly different today because this is the kind of stuff that could go on for forever. I could talk about particular problems and these types of issues hours and hours, days and days. So what I'm going to try to do instead is change your mind. I'm going to try to give you a concept instead of a task to do specifically. So, and I'm going to use some products and go through this in this process. So really this is, most of you know, usually what happens is somebody makes me mad and I write a speech. And so that's kind of how this came about, is because of dealing with forensics imagers and the forensics community. And I don't generally do a talk about forensics in the manner of I go to court and I testify and do those things. Now, a lot of you know that I have been doing this for a really long time. I have testified in federal, local, state, a ton of other cases, and I deal with this on a daily basis. Most of what I have to do now is figure out how I can find an error or a flaw in something else that happened so we never have to go to court. Somebody can decide that they're going to just give up on the case. And sometimes it's forensics people on the other side or other things. So I'm going to try to talk about that a little bit. And this is kind of what I think when I think of these items and these terms. I think of Mark Twain in a lot of cases. Now, this is kind of a long quote from Mark Twain. I'm not going to read it. But what I'm going to tell you is the story goes kind of like this when he gave an interview. He said, when I was a kid, I enjoyed fishing and I was always at the river. I enjoyed everything that went on around the water. And then as I grew up, I became a riverboat pilot. And when I became the steamboat pilot, all I could see now is the ripples in the waves and the sandbar and logs floating down the river. And all of this meant warning or danger or something now. And the romance of looking at the water is no longer the same for me. I can't stand on the edge of a river and look at it and see the beauty. So this is kind of the direction I'm looking at as you look back. And some of you have been doing forensics and do this for a long time. So let's try to find out. How many people do forensics for a living? Only a small number, actually. How many people go out and collect images and use that in other items, whether it be for network captures and things like that, right? That should pretty much be all of you, right? Now, in the forensics world, we use a lot of these kind of things. Now, I can't see the screen, so I'm just going to have to keep pointing at a little picture or something. How many people have one of these imagers? How many people have one of these pieces of hardware, right? So in the forensic community, this is a pretty common thing for people to have. You know, maybe there's a lot more than this. There's a ton more of different ones than these particular ones. And I'm going to kind of hit all of them because they all have some major problems and some flaws. And so I teach a data recovery course. I teach a forensics data recovery course. And one of the first things that I do in this course is I kind of have to break all these forensics guys when they come in. When they come in, they've been taught a lot of forensic stuff, where USB keys are and all these other things. But the evidence primarily, almost always, it's changing a little bit now recently with cell phones and things like that. Primarily, it's always been from a hard drive or solid-state drive. So in this realm, most of the people will get one of these types of tools. And there's some problems with some of these tools. Again, how many people are using these? Like own them, have them, seen them? Okay, so some of you that have done this know that if you see a lot of drives, that it'll work fine for a couple of them. Eventually, you're going to run in some drives that have some problems. 10 years ago, it was almost never a problem. You could buy one of these tools. You could almost always, 90, 95% of the time, go out on a job and make an image and do something. Now, these imagers, they're going to run forward on your drive and try to copy every sector, and hopefully it will make it to the end of the drive, and you won't have a problem, and then you'll have an image. So I'm skipping all the other forensic stuff that happens in between and all the other things that you've read about or had classes on. So in this process, when you're actually grabbing the image, drives are expected to be good. But now, today, we have a tremendous number of drives that have an error. So what happens now today is you get one of these imagers, you go plug it in, and you pray. That's pretty much what you do. You hope that it's going to make it through it because you have a 3 terabyte drive And these imagers are going to go and run against the drive, and then hopefully after 2 days it doesn't fail and you got to start all over again. Because these things run concurrently, expecting to copy all the sectors. They don't normally, if they can survive the error at all, they do not normally skip those particular sectors and then come back to them and do them or anything. They usually fail. They usually just flat out fail. Or you'll get some weird things that happen. Like after you've seen enough of these, and at least using these imagers or going through this test, and I own most of these, as well as all versions of software. Now, I'm not really talking about software in this talk, because if you've got a computer and you've got a DD image that you're making with a tool or something like that, you are actually at a significant disadvantage using software. Hardware has some real advantages with regards to being able to talk directly to the drive using a known ATA controller that's in the device. It has some timing advantages. It also has the ability to turn off the power and turn things back on. And I wish I was talking about these tools when I said that. But these tools should be implementing those things. All these years, in 20 years, very few of these have made a change at all. Really what they're doing is they're just making some interface changes or some hashing changes and some things in the back end. So that's kind of the synopsis of what we're going to go through in this. Most of the time, the whole point ends up being something like this. Now, I like interfaces. It's awesome. And this may be the last existing thing that we were missing that was Star Trek. This is actually a Logicube Forensics Falcon. And it does multiple drives, does imaging, it's one of the highest end tools out there that you can buy. It's roughly $3.5 grand. And it does imaging on everything from SAS to SATA drives. And you can copy these to a DD image or to another clone or another drive and look at them. And the interface is very pretty. As you can see, it has a lot of really cool buttons on it. And some of you are going, wow, I might need to get that or do something. And I'm not picking specifically on Logicube. Every single one of these companies almost exclusively has all of these problems. And I'm also not talking about only damaged hard drives. Because some of you are going to go, well, I had a good hard drive, I imaged it, this is what I have for evidence. How many people have testified before? Wow. I guess forensics people just aren't making their way over here. So a lot of people even have done forensics don't end up testifying. So that's the other thing. I do criminal cases and I do things like that. Part of the problem with these types of tools and these interfaces is that, and when I talk to these vendors, this is the part that makes me mad, is I'll say, well, look, how do you do X, Y, Z? What happens if you hit this error? What happens with the content that you actually had an error on? Anybody know what it puts in the location where the content had an error? What do these imagers put there? Right, 0. That's what they fill them with. They fill them with zeros. Somehow that's acceptable. Like, I didn't get the evidence, there was an error, I noted the evidence, had an error in these sectors, and I filled them with 0. But I don't do anything about it. So part of my problem is, well, what about the stuff I can get? So this is where, when I'm talking to these vendors, part of what happens is that the ego gets in the way. Like when I'm talking to the vendor and I say, hey, I'm dealing with this problem, what does this mean, and why aren't you checking for this particular type of error and then going back and getting it? And they're like, we're forensics. We're higher up than you data recovery guys, so maybe you guys don't know what you're talking about, and their ego's kind of getting in the way. And this is where I kind of start to get pissed. They're not listening, they're not looking at this, they're not doing anything to advance, and they've made almost no advances in 20 years, almost none. And you'll see what I mean here in a minute. This is what I call the unknown unknowns. So you guys have probably seen this clip before with Donald Rumsfeld. Like, they don't know what they don't know. So they're not adding them or doing anything to actually improve the products so that the evidence that is used to decide in court whether or not you're a criminal or whatever else happened actually gets the evidence. So they're missing pieces of it or filling them with zeros or doing other stuff. And it gets far more robust than that, so I'm only going to cover a couple of those items. But any of those imagers, if they hit a drive that looks something like this, it's over. They're not going to make it through this drive. Usually, they won't handle more than a few errors, and if anybody's used this is what ends up happening. You're sitting there, you're watching an image, it's going great, it's fast, and then all of a sudden it hits an error. Now, whatever time you thought it was going to take, 2 hours to copy this drive, you have no idea how long it's going to take. It could be days, it could be weeks. That's if it survives at all. Or it just quits and aborts and just fails and says, ugh, nothing happened. and you're in a situation where you've got a lawyer or a cop or somebody else standing there, and you're working together in an environment where there's a table where you've got tons of evidence you've got to copy, and now you're stuck. Okay, so that's what I'm trying to get to. Now, people who testify in cases, they say this all the time. This has always been a problem, that they'll sit on the stand and they'll say, yes, I copied every single sector. I got all of the sectors on the drive, and here it is, and here's my hash. And then they will present that evidence. And that's always the problem, is they always say, I got everything, because you did not copy everything on the drive. There are certain sectors that are reallocated, and these reallocated sectors will actually change their location. There's an area on the hard drive that's called the system area. The system area contains extra spare blocks, and there's, in solid state, it's also very similar. There's some other things with solid state, and I can go there if you want to. But assuming that you have this area where you have a reallocated spot and there's new sectors that are going to be pointed there, when a sector is marked bad, whatever was in the original sector is left there. That's user data. There is user data in that sector, and now there's a pointer to the new sector, and when you copy it, you're actually getting the content in the new sector. And so when you're doing that, what a lot of times will happen when I try to explain this to somebody, like, okay, well, I can take a hash of my drive and compare the hash at the end, and now I know that I actually got a copy of it. The problem is that in the process of doing this, the reallocated sector count can change while it's being imaged. This is a complicated item. I want to make sure everybody kind of gets this. So while you're imaging it, the drive sees something is wrong. The reallocated sector count in the SMART table, if some of you know what it is or don't, will increase, and then the sector will change on the fly while you are imaging it. Now, it's not supposed to happen. It's not, physically, there's code in the drive. It runs, it has firmware. It does all these kind of things. But it's not supposed to happen. It's not supposed to change your data. It's supposed to know this is a problem, mark it, do something else. But it does happen. There are times where it does, and I've seen it actually physically change it and now point to a new location because it could not read that sector. And you were handed data, and you imaged it at the end, you made a hash. So a hash is not done on the data prior to you getting it. It's done after you've got something. The hash is the result. Then you can compare that hash to some other hash. So I made a file, I hashed it, now I gave it to you. Now I can compare the two hashes and see whether or not it's the same file. But the drive wasn't hashed. There was no number on the drive that said, here's what I started with. So while you're imaging it, it can change. So most of these tools, this is what ends up happening is, while you're imaging, these are the LBA blocks. You can see an LBA block might actually be marked, and then it will go down into the reallocated block, and now you're actually missing some data, or it happened and changed while you did it. Now that's kind of like the worst faux pas that you can have when you have evidence, is after the guy's arrested and you took the evidence, that something changed while you're actually doing it, if you can prove that it changed, right? In a lot of cases, some people might say, hey, let's throw that evidence out. But that's a whole different discussion depending on judges and different things like that. But it can change. The only way that you would have any indication that it actually changed is this, a SMART table. Now, SMART is not useful for many things, self-monitoring, analysis, and reporting technology. It's not very useful for a lot of things. But there is this one area that SMART keeps, which is the reallocated sector count, and it tells you if it increased. Now, here's the horrible thing about SMART and why a lot of tools don't implement something with SMART to try to check it. What you would have to do is you would have to check it before you imaged your drive. You'd have to pull this table from the drive and save it. Then you'd image your drive, and then you would pull the table again at the end. Then you would say, did the sector reallocated block increase? If it did increase, it changed while you imaged it. There's only two products I know that do this. One is called the Ditto, and the other one is X-Ways Forensics. X-Ways Forensics is actually only software, it's not a piece of hardware, and so I give them kudos for that because they note it in a text file. You have to go read the text file or you won't know that it changed. But one of the problems with SMART is that these are not the number that's in that box for the reallocated sector count that's there. It is not a known standard. So the only thing it does is increase. So you don't know what the increase might mean. It doesn't necessarily increase by 1. It doesn't necessarily increase by a particular number. It's just a number that's stored, and some people guess at what it is. So a lot of times when you're looking at it on your own drive, that's what people go, how bad is my drive? And they'll look at that. It's a kind of an unknown number. But I'm going to kind of go down this path and say, okay, let's talk about the sectors that you didn't get. As you started to image something, this is basically a simple log file that says, hey, you missed some sectors. And that's usually what all of these tools do. And almost all software does this as well. They will just note it. So FTK, Encase, all of those hardware tools, they'll just note it and they'll make a log file and they say, you missed these sectors. Everybody familiar with what I'm saying? So here's what I'm going to say that makes a difference. And this is what I use in court. So this is one of the reasons I don't normally do a speech like this, because I'm actually using these kind of things to get you if you're going to testify. So if you're going to testify, I'm going to go after you and try to knock it out before we ever even have to go to court as quick as possible. And it's going to be something like this. So you're going to be sitting on the stand, and this has happened, so it's happened in depositions and other stuff. You're going to be sitting on the stand, and someone's going to say, hey, well, there was 12K that was missed in those sectors in your log file. So this is something you already did. You made an image. You're a criminal. The police came and got you. You made an image. Now, later on, I'm getting the image, and the police say there was 12K that was missing. In my mind, what I'm going to do is say, hey, well, then what was in those 12K? And this is what lawyers do. This is what a defense lawyer will easily do, is he'll walk up and he'll say, hey, tell me what was in those 12K. It's like they always talk about exculpatory information. Whatever you didn't get is exculpatory, which means it actually helps the bad guy, and that the bad guy is missing data that would have helped say that he's a good guy. Everybody with me? So this is what would happen. You're missing 12K. What was in that 12K? Was there a combination to a lock? Maybe so. Could have been important. Maybe it opened a safe. Could it say not guilty? That's the other one. The whole point is you're sitting in front of a jury, and anything you say leaves an impression on their mind. They don't know what 12K means. They don't know what sectors and reallocated blocks. They don't give a crap about any of that. What they care about is, sir, what was in there? I don't know. Could it have said not guilty? And as soon as you say that, the jury now sees that. Now you actually have a chance of creating doubt. Or even prior to that, if the other side knows that you might do this, it may not even show up in court, right? They don't want something that there's no answer for. Lawyers never ask questions. But now here's what I'm going to show you that happens. And if anybody's been doing data recovery, even if it's not forensics, and you've been doing data recovery or copying stuff, you've seen something like this. In forensics, if you have an error in that block, you might get a picture that looks a little bit like this. Now, you've all seen something like this probably before, right? A corrupt image. And there's usually going to be like a spot, and it's just like this. There's a little block on the side, and it like starts and it messes up, and then from there on, it's 0, right? So the forensics image, missing 12K, 0 to the end of the file, right? And then people will go, well, this is the best evidence. This is what happened. 0 was acceptable. My tool marked it and said it was 0, and so I know those are bad blocks. And they show you this picture, right? It's not really, right? So what if I had some special techniques and some special tools, and I could go and read those sectors? And when I read those sectors, I am then, after you've already testified, this is what happened, I'm going to sit on the stand and I'm going to show the picture I recovered. So there definitely is going to be a difference in the change. Now, by definition, does that not tell the jury, I'm better than you? Right? These are the kind of tricks that come up. It's like, flat out, sure, he used this other tool, and that's what he did, but I actually got the data back, and I can present not just this picture, but maybe 20 others. Maybe there was some other file. Maybe I can actually prove what was in those files was not what they said it was. Does that make sense to everybody? So all of this has to do with techniques to copy the stuff. So the forensics imagers aren't doing any of this other stuff. They're not doing these special advanced techniques, and they're not trying. They're not adding them. They haven't added them in 20 years. They're just selling the same product again and again. So why would we use these other products? This is the big question. And so the biggest one is, so I wish I could say that you are like always in your lab and you're always working at a table over by yourself as the tech that most people are. But this isn't the case when it comes to the legal stuff. When the legal stuff comes up, what happens is a lawyer calls the office and they say, okay, tomorrow we have 2 hours and I need you to send a guy over and we're going to copy these hard drives in this case. And so you have 2 hours, 3 hours to do something. And, you know, according to the drive speeds that you would actually get, because a lot of these are really fast copiers. I mean, some of them can do upwards of 500 gigs an hour. On average, you usually get about 300 gigs an hour, but for the most part, you can get 500 gigs an hour on high-end, very advanced tools. That's pretty fast, a terabyte in 2 hours. So usually it's going to be 3 to 4, but if there's an error and something happens, now it's going to be 6 or 10 or 12, or you don't know. And that's the problem here. Some of the tools that I use actually can be accurate and can actually do these things without it taking that long. The other problem is speed of setup. Like, you want to be able to walk into this office and you don't want to spend an hour going, here's some computers I got to put together and monitors and stuff, which some of these other tools are advanced and you have to do that. You want something that's quick, it's a little box, you push a button and you're done. And it's simple so that when you're there, because what happens is the lawyers are talking to you. They're not walking away and saying, call me when you're done. Somebody's usually standing there, or the other guy who's the opposition is standing there watching you. Everybody's watching everything. And they want to make sure that you don't make a mistake. And if you push the button on the wrong side, on the wrong drive, and you overwrite your drive, wow, that's a big deal. So these things make it very easy. You've got, you know, source and destination, one button. If they want 2 drives, some of these tools also do 2 drives at a time. So they're very useful in that. What I really need them to do is all this other stuff that they're not doing and advancing in it, because what happens if it has an error? Now we got to like reschedule, come back in 3 days, or we don't have the evidence, and sometimes it overruns into the court and the judge says you had time. Sorry, you don't get it. So it's simplistic and all these other things. And this is the other problem, is that no one knows what they're missing in this process. So this is the other problem with these tools. No one knows. So let me talk about the state of these tools really quick. One is they're using the same old basic DD engine in these things. So DD, the old DD that's basically been around, and a lot of these tools, they're embedded Linux devices. They're using DD or a variation of DD, and they're not doing anything special. It just runs forward. Even DD would die in these things. Just running forward, hits a spot, dies. So they haven't updated them. Very little at all. Now some are using a few more variations of DD, like there's this one that's DCFL DD. So the Department of Defense Computer Forensics Lab created a copy, and you will notice what it does in the list is it does things on the side like hashing and things like that, but you won't see any error recovery process in here. It doesn't do anything different on the error problems or anything else, redirected blocks. It doesn't know anything about those at all. It just creates a hash or does a few other things on the side. Now, I know some of the guys who wrote this, but you know, as a whole, there's nothing wrong with it. You just have to use the right tool for the right thing. And if there is an error, you've got to know to stop and start all over again and do this again. But there is a tool out there that's been written. It's in the Linux community. It's called ddrescue. Now, ddrescue has some of these features where it can say, go forward, go backwards, copy some sectors, create granularity, and do these things. Do you know how many of these tools use ddrescue? That's right, 0. Not a single one of them said instead of using one of these other versions, or maybe let's take some open source code from ddrescue and build it into our product. So one of the newest and most advanced ones is the Ditto. The WeBTech has a Ditto processor, and they're using DCFL-DD. So they're using that tool, and they can do some hashing and stuff, but they also still have the same problem. They don't do any error correction. But I'll give them points for one thing. They did add smart logging for those features. So the Ditto actually will collect the smart information at the beginning and smart information at the end. And so that one and X-Ways Forensics, which is software. Do you know how many others collect the smart information at the beginning and the end? I couldn't find a single one. I couldn't find anybody else that did it except Ditto. So no one knew the reallocated blocks. Next, so this is the other thing, is that every sector actually has a specific error. Did you guys know that? Like most of the time when you see a copy of a drive, it just says bad block, and it fails or quits. No, they have specific errors. This is a very high-end device. A drive is a full-fledged computer, and it knows everything about what's going on inside of it. It has extreme diagnostic capabilities. It knows what happened to the sector and the specific type of problem. So, but in this case, none of those devices, the hardware ones, know anything about the sector errors. They would never make it through a drive like this. All those little green dots, those are errors. those are errors I recovered on this drive and got a pretty good copy of this drive. In this case, none of those other tools are going to do it, and they won't track or do anything with those errors. Then the next thing is, these are just 3 major points that I'm making because there's hundreds of points I could keep going. But since they don't know how to deal with the errors, instead of tracking the errors and noting what the errors are, they're just going to mark them as 0. And as you already know, I find that unacceptable. So let's talk a little bit about that in a minute. Here is the problem for me that makes this a big deal. In the legal system, you're using a tool that somehow can gather zeros, and it's acceptable, and they might use it to charge you with a crime and decide. It's also used for a deciding factor sometime on how long your length of your stay in prison is going to be. And on the other side, you've got data recovery, which is the forensics guys consider the lower end, but we recover all your porn. Like, we can get 100% of that back and get your full picture, and I could show it to you, and almost always get a complete picture of that stuff instead of what you actually got in forensics with a bunch of zeros on a damaged drive. So let me point out the sectors. And this is the way the sectors look. This is one sector. Now, there is some things in here, and I don't want to go too deep into this, but it took a while for me to lay this out. But this is basically what a sector actually looks like. It's not just the 512 bytes you see down there in the bottom. There's a lot of stuff in the sector. And the drive knows each one of these things is associated with a particular type of error. Data recovery tools track the error. They actually know what to do with specific types of errors. If I get this ID not found problem, I actually have a process that addresses ID not found. So you have specific things that address each one of those errors, and not just that 512 bytes. Which basically all your other tools are only gathering the 512 bytes. They're just a dumb request. They just say, give me the next sector, read it in, put it away. I can show you the code. It's just dumb. It just doesn't do anything special. Now, here's one of the problems. This is what's going to make it worse. And today, at least since 2010, it should be very apparent to people what is about to happen to us, because this is where we get screwed. So this is what that sector, that all the content I just showed you in a sector, is in each one of those blocks. And that block is how big? 512 bytes, right? 512 bytes per sector. How big is a bad block? 512, right? So when you're recovering something, all the sectors around it can be fine, one can be bad, and you're only missing 512. Well, today, most of the drives have started changing. Have you guys noticed this? If you read the label and you see what it is, it's a 4K sector. It is now an advanced drive, and they've been gradually switching now, and so as XP is dead, XP actually still needed the 512 byte boundaries because of partition problems, and that's a different discussion. But at least from this standpoint, we have 4K sectors, and the 4K is now what you are going to lose. You're going to lose the entire block of 4K. So when one is marked bad, you lose all 4K. That's significant. 4K at a time, instead of 12K being bad, I would have had easily 4 times that. That's pretty significant, or 8 times that. So at least from that standpoint, it's a big deal. Now the tools I'm talking about that I would kind of combat this with, these are the more advanced tools that keep adding stuff. Now I'm not trying to say buy one of these tools or do any of this stuff. What I'm trying to say is I'm really pissed off that these other vendors aren't listening to anyone and adding this stuff. I want a cheap, affordable field processor where I could go out and actually image something and get the correct value, or at least inform me of what I've actually got, rather than me have to go buy an expensive tool and try to do everything. Because in the field, sometimes it is only a small number of sectors that are bad and not the whole drive or some huge chunk. So we are talking about a time that it might be a slimmer number. So let me tell you what the tools are that are on the screen there, just as an example. So on the top left-hand side is an Atola disk imager. Now, there's several tools, and there's a new one coming out, roughly between $3,500 and $9,000. They have all kinds of advanced features and really cool stuff. That one can basically do upwards, on good drives, can do upwards of 500 gigs an hour. The one right to the right of that is a DeepSpar disk imager. Now, DeepSpar actually has quite a few advanced features. They can do recovery processes on SAS drives, SATA drives, USB drives. Now, they're the only one right now who can really do a thorough job on USB drives. Now, when I say USB, you know some of the new drives actually have a connector that's soldered to the board, and you can't sometimes take it off or it's encrypted. Well, you can talk to that. It has its own protocol, very much like Ethernet does. None of the other tools in any of the realms seem to be able to communicate with the drive natively, except for this tool. This is the only one that has one, that you can actually take a damaged USB drive, plug it in, and actually talk to it and get correct sectors and get content back, rather than complete failure and it just falls offline. So there are some instances like that where it's going to be very important. The next one below that, on the left-hand side, is called a PC3000. Now this is a $7,000 tool, and its primary function is to mess with firmware. Now this would be where if you made an image of a drive, because here's the big thing. If you're on the other side of a case and you hear, hey, the guy wants to see the original hard drives, then that means you made an error and I knew about it and I'm coming to get you. And so these are going to be the kind of tools where I'm actually going to look at it and say, well, what did he see? What is he missing? How many sectors does he not have? This tool gives me access to everything. All of the tables, the firmware, how you can communicate to the drive. I can fix, read, clear, and I can get back those reallocated sectors. I can get any of that stuff back. But none of these even smaller advances are in the other tools. And then the one to the right of that is called a Cyclone tool made by CPR Tools. And it's actually a forensics imager, and you can actually take it out and go in the field. Now, I give them kudos because they made this a very easy box to use. You can walk out there, you can do an image, and you can do recovery processes. Maybe not all of them, but they have at least tried to do this and do these recovery processes. But it's being sold primarily as a data recovery tool. So at least on that side, there's a lot you can do. Now, one of the problems with USB is very hard to read. You will find that a lot of your write blockers, if you went and got a hard drive and you plugged it in, if you look at USB, you will find that the smart tables and things like that, you almost never can read them. And the reason is because the write blocker doesn't give you access to it. And it's not that it can't, it's that the chipset that they're using doesn't allow it. So you can't make those requests. And that is a big deal to me too. I've looked at a dozen write blockers and finding one that can actually read the smart tables. I got other ones. You can hook up almost anything to any other read-write device and you can read the smart table. But USB is a very difficult thing to do, and maybe they're just avoiding it because they're afraid of it. But the drives are getting more advanced, and the tools need to get more advanced with them so that we're not left there holding the bag at the end because they just don't inform us. So this is one of the things that flat out would kill any of those imagers that are the forensics imagers, without a doubt. Now this is what it looks like when you have a bad head. So you'll see the sectors. This is actually 4 heads in a drive, and when you have a bad head, you have a chunk of red space where it cannot read the stuff. This is where that imager goes, and it retries on that same sector over and over and over again, and then just fails and dies because the next one can't be read, and the next one can't be read, and it never finishes. It just quits. It'll never finish. In this case, what happens with the data recovery tools is they look at the drive, they ask for what's called zone tables, like which heads are talking to which sectors. Let's not copy the sectors that have a bad head. We can actually test them and say which one's bad. Stop reading that one. Let's read the other 75% of the drive and skip that one. Now this is where people would go, hey, but then you're missing some stuff, so how is that evidence? The other dudes are writing zeros. So if you can go back and fix that head later and do something with it, at least you got 75% now. You actually can have skills, and I teach a class on that, coincidentally, on how to fix that head and actually go get that data back. But either way, those other guys have no evidence at all because they didn't read anything past the first block where the error occurred. I can, just by turning the heads off, I can actually read the other items using the correct tool. Now, there's no reason why none of these other tools can't do this. All the hardware tools have access to a chipset talking to the drive. They could easily say, test 2 sectors in each block, see which heads are bad, and turn it off and ignore it and copy the rest of it and note all of that information and log it. Not one of them does it. Not a single one. They don't know anything about the system area, which is where all these log files and all these other things are. Now, HPAs are a special topic. So all these other things that are in the list, these are, smart tables, the P list and the G list are bad block tables, they're zone tables. All these things are important, but none of these things are tracked in any other tools. Now, HPAs, the host protected area, so I don't want to explain what it is, but forensics people would know what that is from that standpoint. But fundamentally, it just reserves sectors of a drive so that you don't have access to them. And so this host protected area is treated a number of different ways by a number of tools. The problem is, it is actually a location in the system area of the drive. It's an area on the platters with which you can store a number. And the number says how many sectors can the guy use. Well, you can change that number. In order to have access, a lot of these tools will say, I see an HPA, do you want to clear the HPA so I can read the entire drive? If you say yes, you just made a modification to the disk. But no, most of those guys don't know it at all. So I know if they got access to it that there's a chance that they modified it. Now, it certainly depends on the tool. Some tools, like the newest Tableau write blockers, they just ignore the HPA setting. They just strip it off and don't even tell you they stripped it off. They just get rid of it, and they just don't show it at all. So then you actually get all of the data anyway by just ignoring it. And so those are things, though, that they did not tell anyone. I'm playing with it. The old one does it this way. The new one does it this way, and no one said. So as best I can tell, they don't tell you. Bad block tables, obviously, in this case, they're not going to know anything about any previous bad blocks, so you can't go get the data that was previously there. If there's a lot of bad blocks, there's a lot of data sitting on the drive that if you could get to it, it's old data that was previously written. It could be password tables, combinations of locks. You know, it's not usually a lot of data. It's a small amount of data, but sometimes a small amount of data is all you need. 33% of the time, I can tell you who you did business with or something about your file system and what the file names were. 33% of the time by reading the other blocks that nobody else can read. That's pretty significant. If it's that high a number, I can tell you a lot of things. This is a very simple thing that only one or two of the actual hardware devices will address, but all of the data recovery devices do. Every data recovery tool addresses timing. So the reason that when you're using your hard drive, that you're in Windows and you got to open that Excel file and you get an error and it pops up and says, oh, I can't read it, error, CRC, blah, blah, blah. Well, usually what happens is Windows has an amount of time that it's going to try to read a sector. So as a sector gets older and it's used more and it goes bad, it may actually take longer to read the sector. And Windows really needs it to be something around 600 milliseconds. So if it's not responding that amount of time, it's just going to say it's bad and give up. So all data recovery devices will be able to increase the time that you read. So you can read it in 1,000 milliseconds, you can read it in 7,000 milliseconds, you can do 10,000 milliseconds, and you'd be surprised, like 85% of the time you're successful reading a drive just because you increased the amount of time it took to read it for those sectors. Only Tableau, I think, is the only one that I could find. The new Tableau TDs, the TD line, TD2 and TD3, added something called TIM, and it increases the amount of time that it actually takes to read a sector. And that's the only one that I can find that I think does that at all. All the other ones failed every time I tried to do something with it at all. But this isn't a very important feature. This is a very low-level important feature that every single one of them should have a way to either increase or do it automatically and say, I'm going to increase the amount of time that it takes per sector, but they don't do it. And this is one of those things, like this is actually a screen from a data recovery tool called the DeepSpar Disk Imager. Look at all the timing you can control. You can control, not only that, you can also control power. You can actually say, while you were reading a sector, you failed. I'm going to turn the drive off, turn it back on, and come back to you and read the next sector. Now, it does not need to do anything in order. All the other imagers read consecutive in order, and when they fail, they never continue on. You never get the last half of the image. These tools can go forwards and backwards. They can fill in sectors. They don't have to be in order. None of the data recovery tools have to be in order. You can fill in sectors. It's just like a BitTorrent. It's a BitTorrent of hard drives. All the data recovery tools can fill in all those sectors as they go. None of the forensics tools can, except the one piece of software is ddrescue, and nobody uses it. There's other settings in here too where you can say skip sectors, like I know every time I have this type of error, skip 200 sectors and I'll deal with you later. I'll come back and deal with you later. There's nothing that's defined here as a one-time only. All forensics imagers do it one time only. They do not make a list and come back later. They do not reverse and come backwards after they finished an image. At all. Not at all. That seems like a very simple and straightforward thing to do. Like, okay, I couldn't read you forward. Why don't we try reading you backwards? Let's go to the end of the drive and come backwards and read you. How obvious is that? All of the data recovery tools do it. None of the forensics tools do it. And then that's the point about reverse. So, and then in the same process, there's one other thing that's now this is a little bit more advanced, and this is a higher end thing. All the green boxes that you see, the squares, those were all read successfully. The ones that are like the green, the darker green squares, if you can see that color, that are completely filled, those were read using something called ignore ECC. What happened is that 512 bytes, ECC, error correcting code at the end of that 512 bytes, is used to compare and say, yes, you read me correctly. If you did not read me correctly, then throw me away and give me a 0. That's how those other tools dealt with it. These tools in the data recovery world, what they do is they build an array. They say, hey, give me the 512 bytes, and I know something's wrong and it doesn't work. Maybe ECC is screwed up. And then keep giving it to me. Give it to me 99 times, and I'll build an array, and I'll see which ones won 50% of the time. And it actually looks at the bits and says, I won this many times. And so instead of getting a sector filled with 0, I get a highly educated guess. The highly educated guess, in most cases, is perfect. You don't even notice an error in the file or in the JPEG or in any of the stuff. So it actually still comes out looking good rather than 0 from the top of the head down. Amazing. That's the same idea to me as this. You took your wallet out and you had $512 in your wallet, and it got set on fire somehow, maybe last night while you were sleeping. And you put the fire out, and $511 are in good shape, and $1 is burnt. So you throw it all away. That doesn't make sense. Why don't you keep the stuff that's good? Just because one of them is burnt doesn't mean all of them are bad. And that's exactly what the forensics tools do. They throw it away and say, 0 is okay. It really is. It's good. That's exactly what all of those tools do. Now, there's an abundance of things. I can go over like 100 different things. But my goal here is to wake up the community of forensics imagers to make them pay attention. Now, this isn't all. It's, I want to show you one other thing that I find very, very important because I'm addressing the 3 topics. The first one being that it contiguously images. The second one, it doesn't know how to deal with any kind of damage. And the third one being you are blind. They didn't tell you anything, and they didn't log it, and they didn't inform you. So let me show you. On this list, these are all the other things you're missing. Retrials and sectors, going backwards and forwards. Switching modes. There's something, we had old PIO mode versus DMA mode, and there's 2 different modes for that, LBA 28-bit and 48-bit. None of the forensics imagers try any of those. All of the data recovery tools try them all. They can copy a sector sometimes that nothing else can copy because they switched modes and went back to an old school way, kind of like when you read, when you would have a CD-ROM and it would be 52X and you'd have jitter and you couldn't read and write, and you'd go back and they say, oh, set it to 1X or 2X, and then it works fine. That's exactly the same thing. This isn't a hard concept. This is the same idea, and no forensics imagers implement it at all. But the first one on this list that I find important is blind operations. Now, what happens sometimes is you're imaging a drive, and something happens in the head, times out. Like it actually physically will get an error, time out, and you'll watch it, and it'll go to the end, and it'll finish, but what you got from the middle to the end was 0. Anybody ever had that happen? You copy a drive, and you look at it, and you go, this isn't 0, it was fine, this stuff is fine. You go look at the drive, it's fine. But while it was imaging, it got 0 for like the last half of the drive. Anybody had that happen? If you see enough, it will happen to you. It happens quite often in forensic stuff at all. And so what happens is, you see here on the bottom of this picture, I'm picking on Logicube again. On the bottom, you see those 2 little green bars? Those 2 little green bars are your thermostat bars that basically go across and they just say, I'm almost complete, I'm almost complete. Microsoft time is this, I'm almost complete. And that's what they say at the end. You're used to seeing this. This is every tool we ever have, right? Why? Why do we only have that? That sucks. Let me give you a quick example of a video. Now, Dimitri, the guy who actually built Atola, made this little video. I have 2 of these Atolas, and they are awesome machines. But let me show you, I had some input to this because I told Dimitri one thing, I was blind and I couldn't see. So he added this, and pretty much all data recovery tools have this function. So I'm going to kind of show you, hopefully you can see the video. I want you to watch, I know you can't read anything, it doesn't matter. Watch the bottom half of the screen as it's imaging. So you'll see it starting to go across an image, and you'll see it start to actually go through the blocks. And while it's going through the blocks, the bottom half of the screen, nice and clear out here, while it's imaging, you can see the sectors. You can see what the content is while you are imaging it live. If a sector timed out and you got zeros from there on to the end of the drive, you would see zeros in those boxes. You actually know live in real time while you're copying it that something went wrong. How amazing is that? Why don't we have that in every tool today? That drives me crazy. Like anything you're copying, why not have a little hex box and make it part of the actual part where you actually say, hey, you actually have some good stuff. It's good. Thank you. But none of the forensics tools have it. Only the 4 data recovery tools or the slew of the data recovery tools actually have something like that where they can control that time and you can actually see it. But every one of them will have something similar to that. This is one of the other ones from the DeepSpar. You can see in the bottom half of that box, you can actually see just like that, the code going across. You can see whatever in hex is going across in your imager. This is the worst part of all of it because all these other ones, there's no reason why this Logicube one right here, it's got a nice LCD screen. Why not pop up a little box and show me while it's imaging what's in those sectors? Why are we missing that? They won't listen to me. I tried. I talked to these people. And again, they treat you like you're dumb or you don't know what you're talking about or we have no idea why you need that. Why do you need smart? You don't need smart. Screw smart. You don't need a box that pops up and tells you what you're imaging. We got a little thermostat bar at the bottom. And when there's an error, we log it. Why isn't that enough for you? Like, they just don't get it. So this is my assessment of why. First thing is ego. Like, all these guys are hired to be like the top of the line. They're in there to sell a product. And the developer who is making it for them, who gets hired to do that, is the same thing. He's like, I'm the expert. I have got to do this. Rather than having an open mind and doing something about it, they won't accept it at all. So I'm trying to change their mind. I'm trying to give you an idea. There are other ways to do this stuff. Why are we still old school? Why are we still doing this stuff? And it's worse with solid state. Solid state, 2 times in a row, you may not get the same hash. We have all kinds of other problems with solid state, which they're still using these tools for. Things change with solid state on the fly. You don't have any control whatsoever. Why aren't we building tools? The other thing is these guys do not know how to deal with the problem because they never go and find out. They just think the forensic community is higher up and a higher level. It's like a chiropractor doing massages. He thinks he's the dude and a massage is nothing, but they sometimes still do them. So at least in this realm, this is the problem, is we got forensics thinking the other one is a lower level and that the real stuff is actually happening in the data recovery, not in the forensics. And here's the most important one. The market has decided your interface and looking like Star Trek is far more important than what happens underneath. This is the same as the previous talk where she's talking about the car. All you're looking at is the outside of the car. You're not looking at anything in the dashboard. How can you tell anything? You have no idea. All of the forensics people are being misled. And then the last thing is they count on your ignorance. They count on you not knowing that these other things happen, so otherwise you just buy the other product. You just say, screw it, yeah, for $3,500, at least I have the right answer and Scott's not going to come after me while we're in court. They're counting on your ignorance and not knowing that they're not doing stuff, so we can't seem to demand it from them. As long as we're buying their product, why should they work on this other section that's not sexy? So you are blind, and that is pretty much the end of my talk. If anybody's got any questions. I do teach a class here next month, DC. I'm teaching a class on data recovery, 5 days, 12 hours a day, physical rebuilds and how to fix heads and sectors and do the whole thing. So if anybody's interested, look me up or talk to me. But just make sure you're paying attention to this crap. Yes, so his question is, have I had any success in blowing this other stuff away because they have made errors? Say that one more time? All right, so any of their errors? Yes.
No, it's the word saying that you're not scientific, therefore you can't talk in court. Have you been able to blow them entirely?
Yes. Okay. Yes, so again, as far as I understand the question to be, not being scientific or not having to do this from that standpoint, am I been able to actually eliminate? Yes, and in the state of Georgia, they require you to have a PI license in order to actually operate and do computer forensics, which is their requirement. And so while while this is scientific, that's as scientific as Georgia seems to get. So, but I have like 32 certifications in this or whatever. But I have been able to get evidence eliminated based on some of these errors in using a scientific method as best I can describe to you in order that that happen. But I'm happy to give you proof of those things if you want to know.
Second question. With this level of high testing tools, do you have any problems in
Yes. All right, so anytime that there is this is the question was, anytime that there is a child pornography lab, anytime a child pornography case comes up, you cannot get into the lab. That's part of the problem. So you can get into the lab. You usually have to have a court order. You usually have to have somebody who's actually going to say, you can do this. I get hired in, and I have done child pornography cases, unfortunately, but that is ultimately the thing is that sometimes I can't leave equipment there, so I can't be there for like 16 hours or leave stuff running, but I have actually been successful in court orders at being able to do that before, where this process is going to take 16 hours. I can't do it in one sitting. Usually what happens is, and I call it my ice kit because I used to do some immigrations and custom stuff, and I used to have to keep everything on a laptop that I would only carry into the facility that I'm working on, and it had no internet connections and no other way, and when I was done, we pull out the hard drive and they crush it, and that was it for the case, and I take the rest of my equipment out and go. And I have been successful both in doing cases that way, and I've also been successful in getting a court order to allow my equipment to sit in a room by itself for 2 days, 3 days, and then I come back and do it. So it does happen, but I know anytime somebody says criminal or child pornography case, I'm actually at the police station. The nice thing is, all your other forensics jobs, you like work on them all the time. Like you're at home, you're in your labs, you're at your office, you're working all the time, and it never stops. You get phone calls and you have to go look at the data. In criminal cases and stuff that the police actually has, you only get to see it that long. So when you're done, you're done. You just go home with your notes. And that's it. Thank you. Can you speak? I can't really hear. I'm sorry.
I guess kind of theoretically one more step ahead in forensics versus anti-forensics. Let's say you're a hard drive manufacturer who wants plausible deniability hard drive.
Yes.
You've got these tools out there to ultimately implement
right.
recovery. Strikes me like that blocks are going to be pretty easy to see that they're technically recovered from the perspective of a hardware on hard drive. Could you, as a hardware manufacturer, just build in something that's going to start spitting out garbage when it detects that blocks it?
So if I understand again your question, because I can't really hear all of it, but I'm assuming because you're doing the anti-forensics, your whole point is, are there ways that we can store things into bad blocks, or are there ways for us to actually store other data on the disk by which we can not be copied by police or whosoever, right?
Or to just figure out a way of detecting that the forensics is going on and start spitting out.
Yes. Well, of course, you know at this point about Travis Goodspeed's stuff, and I actually helped Travis a little bit a few years ago because he asked me for like all the Seagate commands and all the other stuff, and so I've been in those rounds, and of course you also know about the NSA stuff with firmware and stuff, because years ago, because I've done plenty of hard drive talks, and that was one of the ideas I even had in like 2007 and 2008, is there's plenty of space on these drives, you can embed stuff in the firmware, and you can do all kinds of stuff. The one tool that's called the PC3000 actually gives you access to all of it, and you can modify, embed, change, and do anything to those. But as a caveat, let me do the anti-forensics thing for a second. You have one very easy thing to do that nobody seems to ever do if you wanted to hide data. And that's the fact that you know which sectors that the hard drive uses for each head, and you can turn off a head. So why don't you just write all the data you want on one side of one platter and turn that head off? The rest of the drive will function normally, and you can even install an OS and do everything you want. And no one anywhere, as you fly around to anywhere, will ever know that the head is turned off. When they image it, TSA, anybody could take it, they would never see that data at all. So sorry, bad guys, sorry, TSA, sorry, whoever, but that is an easy, straightforward thing to do. Buy a tool, you can do it in an hour. Does that help? Answer? Yep. So the question is, because I said that the hash can change during the process of imaging, that at the end you have a hash, and then you can only use that to compare it to the other copies that you give, how do you actually get a hash at the beginning? Well, you can't get a hash at the beginning. That was one of the reasons why I said the only way you know a sector changed is if SMART tells you that the tables were updated, and that tracking those tables would be important. None of the forensics tools are tracking those tables. there's data recovery tools that track those, or you can actually plug them into certain types of write blockers and actually read that yourself before you image it and try to get a table, because you cannot hash it prior to that. Anytime the head touches it, it's going wrong. Now understand that this would be a piece of code that's kind of running rogue inside the drive that's not supposed to do this. It does do it sometimes. It does sometimes happen. It is not always, but the best way for you to know in this entire process would be to track the smart table so that you actually know what was reallocated and what wasn't, or you can have like a PC3000 or a firmware tool that can read the blocks from both of them. So you actually get a copy of both of them.
Okay, my question is relating to DoD, kind of along the lines of like the Bin Laden raid where they went in and...
Yeah, Navy SEALs went in and did the Bin Laden raid, yeah. I've done a few training things with the Navy SEALs. I'm not really sure I can tell you too much about what they used on the back end. I can tell you on the front end that I had been involved in some of the training for the processes and the methods with which that some of the SPAR team and the Navy SEALs used. I don't know which people or which processes that they used. How's that?
Where were you on that?
How do they put the errors out of ping pong ball?
How do they put what?
The errors out of ping pong ball.
Repeat the question again.
How do they put errors out of ping pong ball?
How do they put errors on a ping pong ball? Is that what he said? What? Like 6 people say something and now I can't. Come up here and ask me. I don't.
That was not what my question was.
Okay.
How do they put the air inside of ping pong balls?
How do they put the air inside of a ping pong ball? I guess it's a trick question. Is this like you want to hire me from Microsoft or something? Where are you from?
I don't. Let me go ahead.
So I think they just seal it. I think they just melt it together. Right?
Can't tell us where you were.
Yes, there's a lot of secrets in this industry.
The question I had was whether getting bit level information is codified in the rules of evidence somewhere.
All right, so the real question, if I understand it correctly, would be the guess that we're getting by using the array to read ignoring ECC, that guess that we have, is it acceptable, or would it be acceptable in court? Is that the...
Why not just file up the backup? Well, why do you have to get down to bit level?
The reason that you have to deal with evidence is because it has to be handled as a whole. Most of the time, so for instance, you have a log file and you want to try to use a piece of it in evidence, you usually have to admit the entire log file in evidence. So usually things are treated as a whole. If they go in and they get a hard drive, a lot of times they will try to treat them as a whole. But you are correct in one item from that standpoint is that when you are doing this, the idea now, because drives are getting so big that we may not be successful at imaging them at all because they are too big for us to do in the time limit, that maybe we would do a folder or something instead. Well, so the new thing is, and this is what some of these tools have been adding in, and I didn't go into it because it's a very advanced topic, but let's say you have a sector that's bad. Well, the big thing is, do you know what file it's in? And yes, so if you do know, then what you do is you don't choose that one for your evidence files. When you have pictures, and let's say it's a child porn case, you choose the ones that you have 100% of all the sectors in those files, and you just don't include the others as evidence. It may be uncharged conduct or some other thing, but that's not going to be evidence that someone like me is going to come in and have to dispute. We're going to dispute the charged conduct, and we're not going to worry about the uncharged conduct at all. And so in those cases, we're actually going to deal with what would be 100% of each file. Now, the data recovery tools have become more advanced, and they actually have a process by which now, when sectors are missed, they can actually calculate what the files are in, and in the not just in the log telling you the sector, they can also tell you what the file was, folders and everything. all the way down to that level. So it is possible to do that and just say these are the 100%, not the entirety of the drive.
And see, what I'm looking for is that written somewhere? Is there something you can point to?
So this is rules of what's acceptable in court, right? This is really fundamentally what we're talking about, which a judge in every single case is who decides that. This whole idea that you have something that's court certified and that you can actually walk in and do something, that's completely a farce and completely a myth. The issue is they'll ask you, has this previously been used in court? And if you say yes, then it leans a little bit more to your side. But the judge gets to decide. I'm assuming you've worked on cases like this, so you probably know, at least from that standpoint, that a judge is the final say in what is actually acceptable as evidence. What's that? Yeah, so in that particular instance, you know that there is a lot that actually happens pre-trial of what is actually evidence and what's actually going to be considered in the case. And then you also know at the end that the judge actually is the person who declares we'll accept this or we won't accept this. So I don't know that I can tell you it was written anywhere. Most of the time, if there is actually these kind of arguments, they are happening prior to the trial, and then somebody makes a deal, and it never goes to trial, right? But if you have expertise in that area and you would like to speak on it, I'll give you a mic. No? Okay. How can you recover bad sectors? How often? You'd be amazed at how often. It's hard for me to give you a percentage, but the percentage is going to be in the upper end. It depends on the type of error it is. If the head has actually scratched the platter and the META has not, it actually will look like a CD-ROM, like the stuff will flake off. And so in those cases, that's gone. That's not going to be there at all. So if there is actually sectors that have aged over time, they're slower and slower to read and write, that most of the time, doing one of these methods, you can usually get a very high, large percentage of them up in the 90s. And like that drive that I showed a picture of where all the green spots were all over, it was a pretty bad drive, but the pictures and the things that came from it, the dude was extremely happy because it was all good, intact pictures and everything was fine. So I'm going to tell you it's pretty high actually, more than you would believe. And I would say most damaged drives that most of you have on the table that are doing whatever, I can almost guarantee you that between 85 and 92% of those drives, I could read either 100% of it or pretty damn close. That's it. Thank you.